Hi there. Last lesson we were looking at factoring polynomials that had a leading coefficient of 1, and I didn't go into too much detail about what that really means, but so I thought I'd start off with what that means to have a leading coefficient of 1. So first of all, we can write polynomials in many different ways. Here's two examples. We can write x squared plus 5x plus 6, or we could reorder it and say 5x plus 6 plus x squared. It's the same thing. But this is the normal thing we do, okay? And what we do is we start with the highest order of variables on the left. So when we say highest order variable, what we mean is if we have an x squared, this is the order, so that's a x to the power 2. X to the power 3 is a higher order than x squared. X4 is even greater. So if you had a polynomial that was something like this, typically we would reorder those terms. So it was x to the 4th plus 6x cubed plus 2x squared plus 3x plus 2. So we always have, we start with these numbers starting from biggest down to smallest. So the leading coefficient is the coefficient which is in front of the highest order variable. So in this example, the leading coefficient is 1. So leading coefficient is the coefficient of the highest order variable. So what is the leading coefficient in this polynomial? It's 3, right there. So last day we dealt with polynomials that were like x squared plus 2x plus 6, where the leading coefficient was 1. Today we're going to look at more complex polynomials, and we're going to look at ones that for polynomials that have leading coefficient other than 1. But first, let's review some things that you guys should know by now. When we're factoring polynomials, the first thing we should do is factor out the GCF. I should have wrote that as the GCF. So in this example, there's 2x squared minus 4x plus 6. The greatest common factor in all those terms, all three terms, is 2. So I'd go 2, and that's an x squared minus 2x plus 3. And I can always double check this to make sure I did it right by expanding again. So 2 times x squared is 2x squared. 2 times negative 2x is negative 4x. 2 times 3 is 6. So that checks out. The other thing, the next thing we did last day was trying to identify how we could factor this type of trinomial into two binomials. And what we were doing is we were looking for two whole numbers that when multiplied gave 3 and when added would give negative 2. So maybe we were doing charts like this. So to get positive number 3, it's either 3 times 1 or negative 1 times negative 3. You add up those two terms, you get 4. You add up these two terms, you get negative 4. And you can see that there is no two numbers that when multiplied give 3 and when added give negative 2. So this is actually the final answer. This is as well as you can factor it. You cannot factor that one anymore. How about this one? This one we can factor. We're going to look for two terms that when multiplied equal negative 5b squared and when added together equal 4b. You can think of this as written as a squared plus a 4b plus negative 5b squared. So we could either have negative 5b times b, we could have negative 5 times b squared, we could have 5b times b, nope, sorry, negative b, or we could have 5 times negative b squared. So now we'll try to add these terms. So negative 5b plus b is negative 4b. This we can't do a lot with, that's just b squared minus 5. 5b minus b is 4b, and this is 5 minus b squared. And we can see we have a winner. We have this guy. So if you take a 5b and a negative b, you multiply it together, you get negative 5b squared. You add them together, you get 4b. So the answer to this polynomial, or when you factor out this polynomial, you get a plus 5. Oops, no, that's not correct. That's the wrong one. A plus 5b times a minus b. And finally this one. First thing we want to do is factor out this negative y, because we want something that says y squared. We don't want negative y squared. We want a leading coefficient of 1, not negative 1. So we're going to go negative 1 y squared minus 4y minus 12. And now I'm looking for two numbers that when multiplied give negative 12, and when added give negative 2. And I'm pretty sure I would say that that would be negative 6 and 2. So you multiply those together, you get negative 12. You add them together and you get negative 4. So this thing factored out would be y minus 6 multiplied by y plus 2. There you have it. Okay, so that's kind of a review of last day, and reinforcing that idea of factoring out the greatest common factor first and starting with a leading coefficient of 1. Today's stuff is a little bit more difficult. So we're dealing with complex trinomials. So let's see, two examples of a complex trinomial would be, say, 2x squared minus x plus 15, or maybe, it doesn't matter, it could be negative 5x squared plus 18x plus 105. Can we factor complex trinomials? So that's the question. Can we factor something like this? Maybe not that one, but something like that. Sure, let's give it a try. What if we had two binomials, 2x plus 2 and 3x plus 5? Let's expand it and see what we get. So we get 2x times 3x is 6x squared. Then we have 6x and a 10x, so that's plus 6x plus 10x plus 2 times 5 is 10. So that's equal to 6x squared plus 16x plus 10. Okay, so I know for sure, if I was asked a question, can I factor this complex trinomial? I know for sure it can, because I know it starts off as this. If I knew how to factor it, I'd end up with 2x plus 2 multiplied by 3x plus 5. So yes, it's possible. So the next thing we want to do is think about how could we do that. And there's sort of a recipe or a step thing that we can use here. It's called factoring by decomposition. It's made up of 4 different steps. The first step is to find two numbers that multiply to give you the product of the coefficient of the first term, the coefficient of the third term, and give you the coefficient of the middle term. Okay, it's a lot of words. It's much easier to see how this works through an example. So we want to find two numbers that multiply to give you the product of the first and last term. So the product, here's the example we're going to work with. The product of the first and last term is 12. 3 times 4 is 12. So we want to find two numbers that when multiplied give 12. So I've made that list here. All those numbers when multiplied will give 12. And then we want to also find two numbers that add to give you the coefficient of the middle term. So the middle term is 8. So we add 1 and 12, we get 13. Negative 1, negative 12, negative 13. 2 and 6, we get 8. That's the one we're looking for. So that tells us these are the two numbers that we're going to use for factoring. So the question is, how do we use them? So what we're going to do is we're going to we're going to take this original trinomial here and we're going to split the middle term, and we're going to split it up using these two numbers we just figured out. So that 3x squared plus 8x plus 4 is going to become 3x squared plus 6x plus 2x plus 4. So I split the 8x into the 2 and the 6. And then I can do a little bit of grouping here. I can say that's 3x squared plus 6x plus 2x plus 4. So I've just put some brackets around it like that. Alright, step 3 is find common factor in pairs. So each of these terms I factor out probably the GCF, but maybe not always, to get one term that's common. So 3x squared plus 6x, if I take the 3x out of there, I'm left with an x plus 2. Likewise, in this term I have 2x plus 4. If I factor out a 2, I get 2 multiplied by x plus 2. So there's an x plus 2 there and an x plus 2 there. And finally, I can think of the, I can use the idea of the distributive property, where I can factor out this x plus 2 by using the 3x plus 2. I think some students find that the most confusing part. I think another way to look at it is if I had 3x times, say, a plus 2 times a, I think we could agree that that's a 3x plus 2. But instead of an a, in this case we have an x plus 2. So I have x plus 2 times 3x plus 2. And we can expand those two binomials to see that it works. So I'll do that. I get 2x plus 3x squared plus 6x plus 4. So that's equal to 3x squared plus 8x plus 4. That checks out okay. The next thing I do is I ask what would happen if we split the middle term in a different way. So here I just arbitrarily said 3x squared plus 6x plus 2x plus 4, but there's no rule that I would have done 6x plus 2. I could have split it the other way. I could have had it look like this. So let's try what would look like if I do it that way. 3x squared plus 2x, what's the common factor there? I have an x, so I go, that's a 3x plus 2. And in this one I can factor out a 2, so that's a 3x plus 2 there. And there we have one common factor is 3x plus 2, and the other factor is x plus 2. It's the same thing. So either way you get the same answer. But as an example, you always want to factor out the common factor first. So that's like, here's an example, 10x squared minus 22x plus 4. The first thing I'm going to do is factor out the greatest common factor, which is 2. Great. Now I'm going to look at two numbers that when multiplied will give 10, because 5 times 2 is 10, and two numbers when added give negative 11. So there's a couple of options. Let's see here. 5 times 2 equals 10. 1 times equals 10. But because this is a negative sign, I think we know we must be needing some negative numbers. So how about negative 1 times negative 10? That's equal to 10. And negative 1 plus negative 10 is negative 11. So I think these are the numbers we want to work with. So now I'll write out the polynomial by splitting the middle term. So I get 5x squared minus x minus 10x plus 2. Now I have to be real careful when I put in my parentheses here. That actually changes things. If I put parentheses around this, that means I've now made this 2 into negative 2, because this is like a negative 1 there. Negative 1 times 10x is negative 10x. That's okay. But negative 1 times a 2 is a negative 2, and that isn't what we want. So I'm going to be more careful with this. Oops. So as soon as I do this, I have to change this sign to a negative, because by having the negative 1 on the outside, it distributes to both terms on the inside. Okay, so common factor in this term is just an x, so that's x, 5x minus 1, minus the common term in this is 2, 5x minus 1. So there we can see here's our common factor. So it's 5x minus 1 multiplied by x minus 2. And then the final answer is we have to remember to keep the 2 here. So this is that polynomial factored out. And we can multiply everything through just to double check. So we have 5x times x is 5x squared times 2, so that's 10x squared. 5x times negative 2 is negative 10, times 2 is negative 20x. Negative 1 times x is negative x, times 2 is negative 2x. Negative 1 times negative 2 is 2, times 2 is 4. So we get 10x squared minus 22x plus 4. Yep, that worked out. Alright, you can move on to these questions, and if you need some help, please get a hold of me. Thanks.